Hello, it's Ediford, and in this video I'm going to be explaining the reduce function in Python. The reduce function has three parts to it: the function, the iterable, and the initial value. The initial value is optional, you don't need to put that there. The function, for example, can be timesing two numbers together, and the iterable a tuple that has numbers from 1 to 10, or a list that has numbers from 1 to 10, or a set with strings, for example. The reduce function grabs the first item from the iterable and the second item from the iterable, times them together because of the function, and then stores it as a sum. It then grabs that value, that total value, and does it for the next item in the list, and so on and so forth. What you get is a really large number because factorial is something you should not mess with. Think of a snowball. That is the initial value. And if you roll a snowball down a hill, it will just pick up more and more snow. So you have a snowball that is the base value, the initial value, and as it rolls down, more snow is added onto the base. So now the base grows larger. So as it carries on rolling down the snow, the base itself gets larger and larger because of the previous actions. Think of the reduce as being something like that. The longer the list, the larger the base value or the end result will be as more and more is being added on based on the function. To get to the coding aspect of it, I'm going to first start off simple like always and then gradually get more and more complicated. The reduce function can often be replaced with a for loop for improved readability. This is a for loop that sums up these numbers 1 to 4. And it does this because it grabs the first integer in this list, which is 1, adds it to a total, and then it grabs the next one and adds that to the same total, like that snowball effect I talked about earlier. So when we run the code, we see the sum is 10. If we use reduce, for example, it works exactly the same. We have the sequence numbers, and what the reduce does is applies the first item of that, which is 1, and it stores it as x. It then gets the second item, which is 2, and it stores it as y. Because there's no initial value, it will use the first and second of the sequence. If there was an initial value, it will use the first initial value and the first item on this list. It then adds them together and stores them. It then does the same for the next. So that stored value, which is 3, is added on to 3, which is 6. And then the same thing with 4 and 5 to get 15. In a similar way, the lambda function does the same thing, but it makes it a bit more neater because lambda is a one-off function that you can't recall again. And the answer is the same, 10, because the list is 1 to 4. Lambda, x and y, you declare the arguments is taken in, and then you set the arguments that's going to be put in the lambda function, which is the first two numbers from sequence. In this case, it's numbers. So hopefully you now understand the basics of the reduce function. Now, if you're going to use the function, you might have a scenario where you need to handle more than 2 inputs. And for that, you can use the partial. I made a similar video for the filter function where we had to use partial again. So say you had a scenario where you needed to add A, B, C together. So 3 numbers together. C could come from data elsewhere, like a text file, a CSV file, something else. You grab it from an API, that's C. We have numbers, which is the list from 1 to 5. And that acts as A and B. We are declaring 2 arguments that are going to be added in to this result. The lambda function has x and y. What we're doing is we're calling this variable, which is more like a function, but it's a variable as it contains this. We're calling that, which contains this function over here, sum3. Sum3 takes in 3 arguments. X and y are already covered because of sequence. If you remember from earlier, with the lambda functions, x and y are gathered from whatever list we give it. So x and y are sorted, but C isn't. So when we call this, we use partial to already set the value of C to whatever it was set. Let's say 5. It could be 4, it could be a string, it could be whatever. So it sets it. And then in that partial function, we call the actual function we want, which is adding the 3 numbers together. So when I run the code, it asks data from somewhere. This could be text file, like I said. Let me just say 12. And it adds on to get 63. What happens is x and y, 1 and 2 are called, and then we get c, which is a set value, and we add 12 to it. And then it repeats the same thing over and over again. But sometimes you want to use the third element inside of the list and not some outside number, in which case you need to make a custom reduce function. We have the original function, which is just adding 3 numbers, and the custom reduce has a total, has the length of the list. In this case, it's 9 or 8 because 1 is 0. And then we have a for loop that iterates through it, through 0, which is the very first element, to wherever the length is, which is up to this number 9. And then it does it in steps of 3. So it does 0, 1, 2. So it'll be 1, 2, 3, 1, 2, 3, 1, 2, 3. So the indexes will be 0, 1, 2, then 3, 4, 5, then 6, 7, 8, all separately. It grabs the first index, which is I. So that's number 1. It grabs the second index by doing I plus 1. And the third one by doing I plus 2. It then sums it up. This if-else statement over here, what it does is it checks if it can grab an extra number. Because if this was 10, let's say, you can't do plus 2 on 10, for example, because there just isn't any number to be given. In which case, you call 0, so it doesn't break the code. And 0 plus a number does absolutely nothing to it. If you're going to times it, you might do times 1. And at the end, you store the total up and you return it. And that gets you the number 45. I just forgot to do the print and input over here, so I had to quickly change that. But you get 45 as it sums all of this up. Now, obviously in this scenario, it's pretty pointless to use the reduce function here. But this is just to show you how you would add in the third element. So in another event where you can't just do a for loop or just adding up the numbers together, then you know how to do it with reduce. Now, I kind of glossed over the initial value. I mentioned that at the beginning. But the initial value is very useful if you're going to ever deal with an empty list. It stops errors, specifically a type error. The initial value just adds in 0 to the list. Think of it like that. And once 0 is to the list, reduce. The point of reduce, it grabs a base value and adds onto it until the end of the list. The first value is the end of the list. So it just returns the output, which is just 0. It does, think of it as doing 0 plus 0 is 0. That's essentially what it's doing because it's at the end. If that number wasn't there, it will try and look for the first index or the 0 index, the very first element. It will try and look for a number that doesn't exist to try and make a base, so to speak. But there is no base, so it returns a type error. Because of the initial value 0, it will return that as the base and there's nothing after it. So it does nothing to the base number and it just spits it back out. You can replace this with anything. It could be like 10, for example, but then the output will just be 10. Consider another alternative, which is math.prod. Prod being the shortened version of products. We have numbers 1 to 4 and it times them together. 1 times 2 is 2, 2 times 3 is 6, and so on to get 24. The reduce function will do the exact same thing as we saw earlier, although earlier we did with addition. As hinted in the previous videos, these functions are really good when you're mixing them up with other functions. Here we're mixing up with map, which I made a video on. Map applies an iterable to one function. It applies all of the values in that iterable to that one function. So we have a function, a lambda function, which gets x as an argument and it squares it. That's what this means. And it does it to all of the numbers inside of the list called numbers. So that is the end product. Reduce takes in 2 arguments, x and y, and adds them up together. So if you want to add squared numbers together, you get the squared version of x and y, and you would add the squared version of x and y. I put an explanation bit over here because it can be a bit tricky to understand at first. With functions like these, you always look to the very most inner one because that's kind of where it starts. It starts with the map with the square and the numbers. And once the numbers are squared, you get this list. So by the time reduce actually acts on it and adds the numbers together, it will be doing it with this list and not this list. And as such, it returns 55. Now, it's all well and good knowing the theory of this, because you know how to add in three numbers, you know how to use it with other functions. But realistically, you're never going to be asked to do stuff like this. You're never going to have to do stuff like this in your own personal projects, as work, whatever. You're just not. This is more of a realistic example, but you're trying to find the price range, for example, of a dictionary. This is a pretty small dictionary. It might be like 100 different items. And that is kind of getting beyond the scope of this video. I am going to make a video on that with how to combine these things together in a more realistic scenario. So please check that out if you're interested. And I'll see you there.